Okay, so if you've been anywhere near, well, anything lately, a screen, news, even just chatting with people, you've probably heard all these terms thrown around. AI, LLM, prompt engineering.
Hallucination, maybe?
Exactly. It honestly feels like you're trying to drink from a fire hose. Just so much jargon, new concepts popping up all the time.
It's definitely a lot to keep track of. The field's moving incredibly fast.
So our mission today on this deep dive is really to cut through that noise. We want to demystify the core ideas behind artificial intelligence.
Make sense of the jargon.
Yeah, make sense of it, give you a solid foundation that's more than just, definitions. We want to show the logic behind it all, which is actually surprisingly accessible when you break it down.
It really is.
Mm-hmm.
Once you grasp the fundamentals, it clicks into place much better.
And for this deep dive, we're leaning on a pretty comprehensive set of notes. Covers everything from the basic models, how they're trained, to the risks, the potential downsides, and of course, the real lame stuff, how it's actually being used. Right, so by the end of our chat, we promise you'll have a much clearer mental map of what AI is, how it actually works, under the hood, and what makes it so powerful.
You should feel genuinely well-informed, ready to engage with it all more confidently.
Definitely. So let's jump in. We really have to start right at the beginning. When we say AI, what exactly are we talking about?
Okay, yeah, fundamental question. So AI, artificial intelligence, at its heart, it's technology that lets machines do tasks that typically need human intelligence.
Like thinking.
Well, like reasoning, learning, solving problems, making decisions, that kind of thing. The big shift really is machines going from just following instructions to actually adapting and learning.
Okay. And a huge part of the AI conversation today, the thing everyone's hearing about, is the LLM. Why are large language models so central right now?
Yeah, LLMs. So large language model is a specific kind of AI, and it's trained on just vast amounts of text. Billions of words, really. Books, articles, websites, you name it.
Wow.
Yeah. And this massive training lets them understand context and generate text that sounds incredibly human, coherent, relevant responses. They're central because they're so versatile. Writing, summarizing, translating.
Brainstorming even.
Exactly. Like a universal text assistant. You've got examples like GPT-4, Claude, Gemini. Those are all LLMs.
That coherence you mentioned, it really is striking. But when you say they understand context, how deep does that actually go? Is it real understanding or more like super advanced pattern matching?
That's a great question and a really important distinction. They don't understand, like humans do no consciousness, no feelings.
Right.
But they're absolute masters of pattern recognition. They spot statistical links between words and concepts so well that it looks like understanding. They're basically predicting the next most likely word or sequence of words based on all those patterns they learn.
So it feels meaningful to us, even if it's mathematical probability underneath.
Precisely. They create stuff that is semantically coherent and fits the context extremely well. Got it. Now, LLMs are amazing with text, but this is where it gets even wilder, right? Moving beyond just text, we're seeing AI is handling different types of info together.
Exactly. That's where multimodal models come in. These AIs can process different kinds of information at the same time. Text, yes, but also voice, images, even video.
Like GPT-4o.
GPT-4o is the perfect example. You can show it an image, ask it a question about the image using your voice, and it will look at the image, understand your question, and then respond using voice. All in real time.
That just opens up so many possibilities for interaction. Much more natural.
Totally. It changes the game for how we interact with these systems.
So these incredible LLMs and multimodal models, they don't just, spring into existence. What's the underlying architecture? What's the base layer they're built on?
Good point. That would be the foundation model. Think of it like a really solid, broad-based model. It's trained on very general data covering tons of different domains.
That was a little about a lot, pretty much. And the power of a foundation model is its flexibility. It gives you this strong general understanding that you can then adapt or specialize for specific tasks.
How do you specialize it?
Through things like fine-tuning or sometimes just extra configuration. It's the generalist that you can turn into a specialist.
Okay, that makes sense. So we have these powerful base models, but how do these systems actually learn all this stuff? How do they become so capable?
Right. That brings us to training, the training phase. This is where the model learns by chewing through millions, sometimes billions of examples.
Texts, images.
Text, images, sounds, code, you name it. Huge data sets. During training, the AI is basically identifying incredibly complex patterns and relationships within that data. That's how it builds its knowledge.
Sounds computationally expensive.
Oh, incredibly. It takes massive amounts of computing power and time.
So you train this big foundation model, but then how do you make it really good at something specific? Like, say, writing marketing slogans, or reading legal contracts, or spotting anomalies in medical scans.
That's exactly where fine-tuning comes into play. You take that broadly trained model, the foundation model, and you customize it.
How? More data?
Yeah, you feed it new data that's highly relevant to the specific task you want it to master. So for legal contracts, you'd feed it lots of legal documents and examples of analysis.
Okay.
This lets the model adapt and refine its skills for that niche. It often results in a really significant performance boost for that specific job. It's like taking a doctor who knows general medicine and sending them to specialize in cardiology.
Gotcha. Now, this next idea is something that you, the listener, can actually influence directly every single time you interact with an AI. It's almost becoming a new kind of skill.
Absolutely. We're talking about prompting, or more formally, prompt engineering. It's basically the art and science of giving clear, precise instructions or questions, the prompts to the AI, to get the best possible response.
So how well you ask determines how well you get answered.
Directly. The quality, the relevance, the usefulness of the AI's output is tied straight back to how well you phrased your request. It's not just typing anymore. It's learning to communicate effectively with these things.
It really is a skill. You have to think strategically. Now, something else that's fascinating, and we're seeing more of it, is how models seem to almost think step by step. They don't just give an answer.
Right. That's the chain of thought, or COT, prompting strategy.
Yep.
Instead of just spitting out the final answer, the model breaks the problem down. It reasons through it step by step, almost like it's thinking aloud on paper.
Why is that important?
It's huge because it allows AIs to tackle more complex, multi-step problems that they used to struggle with. Think tricky math problems, logic puzzles, even analyzing a complex scenario. By showing its work, it gets more reliable.
That's a big leap. And maybe even more amazing is how some models can handle totally new tasks, things they haven't really seen before, with very few or even zero examples.
Yeah, that's zero-shot or few-shot learning. It's this really remarkable ability models have to solve new problems using their general knowledge from that broad initial training.
So they can kind of figure it out.
They can infer solutions for novel situations, yes. For developers, this is incredibly powerful because it means you don't always need a massive specific data set for every single new task you want the AI to do.
Yeah.
Sometimes it just gets it.
Okay, let's shift gears a bit into the architecture. When you have complex AI systems, maybe multiple models working together, how do they coordinate? How do they share information?
That's a growing area. We're seeing things emerge like the Model Context Protocol, or MCP. It's essentially trying to create a common language, a framework.
Like a standard?
Kind of, yeah.
Yeah.
Standard way for different AI models or services to share and remember important stuff, the context of the conversation, who the user is, what's happened before, what the goal is, even the sources of information.
Why is that so crucial?
Well, think bigger picture. If you want multiple AIs to collaborate smoothly on a complex task, they need a shared understanding. MCP or something like it is vital for those seamless multi-AI interactions.
Okay. And this leads to a concept where AI feels less like a tool and more like an active partner, something that can actually do things on its own.
Precisely. You're talking about AI agents. These are AIs designed with a degree of autonomy. They can make decisions on their own, break down big tasks into smaller steps.
Use tools.
Exactly. Use external tools and act sequentially over time to achieve a goal, often without needing constant human hand-holding. They can set sub-goals and figure out how to execute them.
When you say tools, what kind of tools are we talking about? Virtual hammers?
Not quite hammers, more like digital Swiss Army knives. This capability is called tool use, often enabled through plugins or functions. It means the AI can decide, hey, I need current information, and then use a web browser to search.
Or do math.
Or use a calculator for precise math. Or call an API to interact with other software, maybe book a flight, check inventory, that sort of thing. It accesses external capabilities when its own knowledge isn't enough.
So with all these pieces, the models, the memory, the agents, the tools, what actually pulls it all together, how do you build a complex, functioning AI application out of all that? Sounds complicated.
It definitely can be. That's where orchestrators or frameworks come into the picture. You might hear names like LangChain or Llama Index.
Right.
These provide the underlying infrastructure, the plumbing, basically. They connect the different components, the AI models, the memory systems, the tools, the data sources, and manage the flow between them.
So they're like the conductor of the AI orchestra.
That's a perfect analogy.
Mm.
They make sure all the different parts work together harmoniously to create something much more complex and capable than any single piece could be on its own.
Okay, let's pivot slightly.
Yeah.
How does AI understand the meaning behind what we say or show it? Not just the words, but the nuance, the concepts.
That's largely down to embeddings, or sometimes called vector representations.
No.
It's a really clever way to translate things, text, images, even audio, into lists of numbers, into vectors.
Numbers. How does that capture meaning?
Well, these vectors are arranged in a high-dimensional space where things with similar meanings end up closer together. So the vector for cat would be closer to the vector for kitten than it would be to car.
So it enables searching by sense, not just keywords.
Exactly. Search by sense. If you search for fast car, the system, using embeddings, can understand what's that. You might also be interested in results about sports cars or speedy vehicles, even if they don't use the exact words fast car. It powers semantic search, recommendations, lots of things.
That's really cool. Okay, and memory. How does an AI remember what we were just talking about 5 minutes ago in this chat versus remembering my preferences from weeks ago?
Yeah.
Big difference there.
Huge difference. And that's the distinction between contextual memory and persistent memory. Contextual memory is the model's ability to hold on to information within the current conversation or session. Think of it like the AI's short-term memory. It's often limited by something called the context window, which is how much text it can consider at once.
And persistent memory.
That's the long-term stuff.
Yeah.
Information the system remembers across different sessions. This could be your user profile, your stated preferences, maybe a history of tasks you've asked it to do before. It allows for personalization and continuity over time.
Got it. Short-term recall versus long-term knowledge storage. Makes sense. Now, AI isn't perfect, obviously. It's crucial we talk about the limitations, the potential problems. What are some key risks or challenges?
Absolutely critical topic. One major one is bias. AI models can inherit unintentional distortions or preferences directly from the data they were trained on.
How does that happen?
Well, if the training data itself is skewed, maybe it underrepresents certain groups or reflects historical societal prejudices or overemphasizes certain viewpoints, and the AI learns those biases too.
And then it applies them.
And then it can perpetuate or even amplify those biases in its outputs, leading to unfair or inaccurate results. It raises really important questions about the data we use and how we audit these systems for fairness.
Definitely a big concern. Okay, what about this next one? It sounds like something out of sci-fi, but it's a genuine problem AI users run into.
You're probably thinking of hallucination.
That's the one.
Yeah, this is when the model just makes things up. It generates a response that sounds completely plausible, confident, even factually detailed.
But it's wrong.
But it's totally false or invented. It's not lying intentionally. It's more like a side effect of how it generates text. It predicts what sounds like a good answer, even if there's no factual basis in its training for that specific claim.
That's a major hurdle for trust, isn't it?
Huge hurdle, especially for anything high-stakes medicine, finance, news. Ensuring factual accuracy and reducing hallucinations is a massive area of ongoing research. And somewhat related, there's overfitting. This happens during training, is when the model learns the training data too well. It basically memorizes the specific examples.
Instead of the general pattern.
Exactly. Instead of learning the underlying concepts, it needs to generalize. So it might perform brilliantly on data it saw during training, but then it fails badly when it encounters new, unseen data in the real world.
Like cramming for a test versus actually understanding the subject?
Perfect analogy.
Yeah.
It hasn't truly learned to generalize its knowledge.
Okay, let's quickly clarify a few technical terms that pop up a lot and help understand how these things work under the hood.
Sure. First, maybe token. You hear this a lot. A token is basically a piece of text that the model uses for processing. It could be a whole word or just part of a word, like ing, or even punctuation.
And why do tokens matter?
They matter because models have limits on how many tokens they can process at once. That's the context window we mentioned. And often, pricing for using these models is based on the number of tokens you send and receive. Then there's latency. Simple concept, really. It's just the delay. The time it takes for the model to give you a response after you give it an instruction.
Lower is better, obviously.
Definitely. Low latency is crucial for anything real-time, like chatbots or autonomous systems. Nobody likes waiting. And one more. Data contamination. This is a problem in the training and evaluation process. It happens if the data used to train the model accidentally includes bits of the data used to test how well it learned.
So it's seen the answers before.
Essentially, yeah. It can make the model look much better during testing than it actually is on truly new data, giving a false impression of its capabilities. Need clean separation between training and testing data.
Right, crucial for honest evaluation. Okay, now for the fun part. How is all this stuff actually used? What are some real-world applications impacting us right now?
Okay, well, one common technique, especially for gathering data, is scraping, web scraping. It's using automated tools to extract information from websites.
What for?
All sorts of things. Market research, comparing prices, tracking news, or just gathering massive amounts of text data to feed into other systems, like training AI models, for instance. Then we have text-to-speech, TTS, converting written text into spoken voice. And the quality now is just remarkable.
It really is. Some voices sound completely human.
Almost indistinguishable sometimes. It powers audiobooks, voice assistants, accessibility tools, makes digital content much more accessible. And the flip side is speech-to-text, STT, taking spoken audio and turning it into written text automatically.
We see this everywhere now.
Absolutely. Voice assistants on your phone, subtitles on videos, automatic transcripts for meetings, dictation software. It's all STT, just making interaction easier.
This next one sounds incredibly useful, especially for folks dealing with loads of information, being able to chat with documents.
Oh yeah, chatting with documents.
Yeah.
This is a fantastic application. You could feed an AI model, say a long PDF report, a whole book, maybe even the contents of a website.
And then just ask it questions.
And then just ask it questions about the content. Thanks to embeddings and semantic understanding, it can find the relevant sections and give you concise answers. It saves so much time compared to reading everything yourself.
I can see that being huge for research or business analysis. Now, what about those experiments where AI gets even more proactive, almost like it's managing itself?
You're likely thinking of things like AutoGPT or Baby AGI. These were really interesting experiments, kind of proof of concepts.
What did they do?
The idea was an AI that could self-organize. You give it a high-level goal, like research the market for sustainable coffee pods, and the AI would then break that down into subtasks.
Like search for competitors, find sales data.
Exactly. And it would execute those tasks, maybe browse the web, analyze the results, learn from them, and then generate the next set of tasks, working in cycles until it achieved the overall goal. All without constant human input.
A glimpse into more autonomous AI agents.
A glimpse, yeah. Still experimental in many ways, but shows the potential direction.
So, last big area. Where does all this AI actually live? How do we as users or developers access it and build things with it?
Okay, a key piece of the puzzle, especially for developers, is the API, the application programming interface.
A connector.
It's the digital connector, exactly. It lets developers integrate in AI models' capabilities, say OpenAI's GPT-4 or Google's Gemini, into their own applications or systems without having to build the model themselves. It's how software talks to other software. Then for actually doing the development, you have cloud-based environments. Things like Replit, GitHub Codespaces, or Jupyter Notebooks.
What do they offer?
They let you write code, run scripts, experiment with AI models, all directly in your web browser. You don't necessarily need a super powerful computer yourself. You use the power of the cloud. It really lowers the barrier to entry for AI development. And finally, a really important part of the ecosystem now is open source models.
Models anyone can use.
Anyone can use, yes, and often modify and improve. The code, sometimes the training data or model weights, are made freely available. Think models like Llama from Meta, Mistral, DeepSeek.
What's the benefit of that?
It fosters incredible innovation and accessibility. Researchers, startups, even individuals can build on top of these powerful models without massive upfront investment. It drives competition and pushes the whole field forward much faster. It's a very collaborative way to advance AI.
Wow. Okay, so we've covered a lot of ground today, a real deep dive into AI. And while it can definitely seem overwhelming, hopefully breaking it down like this, looking at the core concepts,
What they are, why they matter,
makes it feel much more manageable. Hopefully you, listening, feel like you have a clearer mental map now of this, well, this incredibly fast-moving field.
It's about having that framework to place new information into context.
Exactly. And this knowledge really does empower you, right? To better understand the news, to look at claims about AI maybe a bit more critically.
And even just to use the AI tools out there more effectively, more intentionally in your own work or life.
It's about being an informed participant in a world that's, frankly, being reshaped by this technology.
Couldn't agree more.
So as we wrap up, maybe a final thought for you to mull over. Considering everything we've discussed, how much AI can already do, how it remembers, how it's learning to reason and act more autonomously, what new kinds of intelligence might we discover AI is capable of, things beyond what we even imagine right now.